In this problem, I'm modeling for students how long would it take for a penny to hit the ground if it was dropped from the Empire State Building. So we refer back to the standard form of a quadratic equation, y equals ax squared plus bx plus c. But I tell them when dealing with quadratic equations and projectiles, and we talk about that a projectile is anything that you shoot, drop, throw, that you refer to two types of equations that we're going to study today. I first introduced them to the first equation during the warm-up, which is if the height is measured in feet, you're going to use the equation h of t equals negative 16 t squared plus the initial velocity, the starting velocity of the projectile, times time in seconds plus the initial height. And so if we substitute that in for dropping the penny off the Empire State Building, well, if I want to know when it hits the ground, I want to know that the height in t seconds is 0 equals negative 16 is the value we use because of gravity, and we'll go further into that later. T squared, the initial velocity, since it was dropped, if you drop a projectile, it's 0 initial velocity. If you throw a projectile upward, it's positive initial velocity, and if you throw with force downward, it is a negative initial velocity. So I use my arm motions as I show students that to get them to remember what initial velocity is. So in this case, since it was dropped, it's going to be initial velocity of 0 times t, which will just go to 0, and plus the initial height was 1,250 feet. And so if we go ahead and solve that, we would have 0 equals negative 16 t squared plus 1,250. That middle term just goes to 0 when anything's dropped. And then if we take the 1250 to the other side, it'd be negative 1,250 equals negative 16 t squared. And then we just finish solving the quadratic equation. And the easiest way is just the square root method, divide by negative 16 to get that t squared by itself, to isolate it. And then you would get t squared is equal to 78.125. And then you just solve for t by taking the square root of both sides. So t is approximately, if I round it to the hundredths, would be 8.84 seconds before it hits the ground. And in the article that I read with them, I think it said approximately 9 seconds. They went ahead and rounded to whole numbers. So I just referred to the first two paragraphs of the dropping the penny off the Empire State Building, and then I modeled this problem for them on projectile motion and how long it takes to hit the ground.